Hello everyone. So today we are going to discuss number systems. Now before discussing what is a number system, we should know what are numbers, right? Do you think numbers are used everywhere? Can you think of some of the things where you use numbers? Okay, if you go to the market to buy something, do you count your money in numbers? Yes? Okay. And what if you have to go and like have some of the chocolates? Would you count the number of chocolates? Right? So, okay, can you think of some of the examples where the numbers can be used? There are so many. Okay, and if we have to ask, how many friends do you have? Will you tell that in numbers? And what if we ask, okay, so how many subjects you have? Are not all the answers to these questions numbers? So, I think it is very important to know what the numbers are, right? So, for that, what if you go to the market and you have to buy something? How are you going to say that thing is? So, it is necessary that something has to be bought. So, how would you represent those numbers with? You can say, I bought 2 things, 4 things, 7 things, or something like that. But if it is necessary that we have said that you have to buy something, then at least one would be there, right? You cannot say I bought 0 things. We always say we bought 1 thing, 2 thing. If it is made that we have to necessarily buy a thing. So that means these are the possible numbers. Do you think these are ending? No, right? So if the numbers are non-ending, we put these small dashes here, which represents that the numbers are going on and on and on. What do we call that? We call that so on. That these numbers are going on and on and on. So these type of numbers, can you guess the numbers which start with 1 are called as what? These are called as natural numbers. Natural numbers. So, okay, now we know about natural numbers. But why natural? Naturally, if we have to start counting. We start with what? 1, 2, 3. Or if we have to buy and go grab something, we always start with either 1 thing or 2 thing or 3 thing. That is why these are natural numbers, right? Okay, then what about if we don't have to buy anything? How are we going to represent it? Yes, you are thinking it right. Nothing means a 0. And you know who invented this 0? It's Aryabhata, you know. Okay, so 0 was invented by Aryabhata because there was nothing to represent nothing. So that is how we came up with 0. 0, and after that 1, 2, 3, and now you know what is this? Yes, it's so on. Okay, so the numbers which are starting with 0 are called as what? These are called as whole numbers. Can you guess why whole numbers? Okay, so because they are completing each and everything. Something can be bought and something cannot be bought. Everything represented here, right? Completing everything. So we called it as whole numbers. Now, we were like satisfied. Okay, we have found all the type of numbers that are there. But then this thing came that someone bought something from someone, right? And they had to give it back to the other person. Now, the person who had given and the person who had taken both had exchanged one thing. But how are we going to represent that person who has taken and who has given and who has to give back? Someone who has taken the thing and someone who has given the thing. How are we going to represent that? Okay, so if someone had the thing, they had given, right? So they had something, we represent it as 1 chocolate. Let us suppose we're talking about chocolates. So someone was there, he had a chocolate. He gave that chocolate, let us say Ram was there. He gave that chocolate to Sham. Sham took the chocolate. But Ram said, okay, I'm giving you now, but you will have to give it back to me. Right? It was Ram's own chocolate. He bought it with his own money. He gave the chocolate to Sham. Now, this chocolate has been given to Sham, but Sham had to give this chocolate back. Right? If the Sham has to give this chocolate back, will it be his own? No, right? It's not his own. This is something he has borrowed, and something if we have borrowed, we have to give it back. So there was this problem. If we have to give back some things, how are we going to represent that? Right? Because one thing means again someone is already having it, but the other person is having it, but it is not there. They had to give it back. So how are we going to represent those numbers? So because humans are very creative, they found a way. Out of these numbers only, they said, okay, if you have given, it was yours and someone had to give it back. They said, okay, call it -1. We call this number as -1 chocolate. So how many chocolates Ram is having? 1. How many chocolates Sham is having? -1. Why -1? Because we wanted to have an expression to represent something which is not our own. Right? So that is how negative numbers came into being. So -1, -2, -3, and so on. What are these called as? These are called as negative numbers. Negative numbers. Okay, so now we are talking about negative numbers. We know negative numbers. See, there are things. For example, if you have to represent the temperature at very, very cold places, below 0 degree, we know -3, -4, we represent it with negative numbers, right? And the hot temperatures are represented with what do you think? 1, 2, 3, 4. These are obviously called as natural numbers, but what else can be they called as? If these are negatives, the other ones are called as? Yes, you're thinking correct. So those ones are called as positive numbers. Positive numbers, which are 1, 2, 3, which are also natural numbers, correct? Okay, so now we have positive numbers, we have negative numbers, and we have our main number, which is 0, right? So we have all of these, and they said ki these are all different and into different parts. Why not combine all of these things into just one thing? So what they did was they made up a new form of numbers which they called as integers. Can you guess? Can you make a guess? What are integers? The numbers which are having 0, also 1, 2, 3, and so on, and also the negative numbers which are -1, -2, -3, and so on, right? So all of these numbers combined are called as integers. Now what do you think? Writing all of these numbers like this will be convenient for us. So what we did was we made up a notation to represent all of these types of numbers. Okay. So for example, the natural numbers are represented by capital letter N. The whole numbers are represented by the capital letter W. And can you guess what the integers are represented by? No, it's not I. Let me tell you why. See, the integers have come from a German word. Right? Zahlen. So what it means is to count. See, all the positive, all the 0, and all the negatives. Be it taking from someone, borrowing, or there is nothing, or there is something. Everything can be counted here. So it is represented by Z. So you must be thinking, what is I for? You will be knowing in a few seconds or a few minutes, right? Okay, so what is this for? Now we know all of these numbers. Do you think, is there any representation? See, the numbers are so many, right? There are 23, 97, -100. Should we write the numbers just as how they are? There are like so many, right? So there must be some way to represent the numbers and arranging the numbers. So what is the way to represent the numbers and arranging the numbers? Let me show you something, right? Okay, so it is something, a simple thing. I just draw it here, and here is the magic in front of you. Yes, this thing. Can you see what is this? Yes, it's a line. Okay, what if it's a line and I write a 0 over here? And what I do is, let us write 1, 2, 3, 4, 5, 6, 7, 8, and there are more numbers, but there is no space. So, okay, let us go with the left numbers. Let us write here -1, -2, -3, -4, -5, -6. Okay, there are more numbers, we know, right? But there is no space. What to do? We know they are going to go over hundreds and thousands and whatnot. But how do we represent it? So we came up with the notation of an arrow in the beginning and at the end. What is this arrow indicating? See, this arrow means this arrow, this arrow. It means that the numbers are going on and on and on. That is why we put an arrow over there whenever we are making a line. So all the numbers are represented here, right? Positives are here, negatives are here, 0 is here, natural, whole, integers. Everything is there. So this line in which we are putting in all the numbers, this is what we call as a number line. A number line, right? Now we know what is a number line. But do you think any more numbers are there? Okay. Do you like pizza? Even I like pizza. But I'm not that hungry that I can eat one pizza or two pizza, right? Okay. If we are having the slices of pizza, can you count how many slices are there? 8 slices, right? Okay. At the max, I can eat only 2 slices out of this 8 slices. Should I represent that I ate 2 pizzas? Will that be correct? No, right? So how do we represent that? So humans are very intelligent. They also find a way to that. They said, okay, 2 we ate out of 8, na? Let us represent it like this. Okay. How many do you like? What do you think? Out of 8. I'm just assuming that you like, you can eat 3. So 3 out of 8. But do you think this can be represented here? If it is, how is that possible? Okay, so to understand this, let us see. Do you know what type of numbers these are? Do you think these are natural numbers, integers, whole numbers? See, these type of numbers, can you guess what they are making? Isn't it a kind of ratio? So we call that as rational numbers, because it is kind of a ratio, right? Represented like that. So we call it a rational numbers. Can you guess what is the representation for the rational numbers? The rational numbers are represented by, no, not R, Q. Now why Q? See, it's a ratio. That is, whenever 2 numbers are divided, there is always a quotient, right? That is why we represent rational numbers with the letter Q. Do you think there are any numbers between this 2 over 8 and 3 over 8? Okay, let me tell you there are. If you are thinking there cannot be. How? Alright, let us do this one thing, that we multiply and divide this number with 10, and same we do with this one. Okay, so what are the numbers that are formed? It is 20 by 80 and this is 30 by 80. Okay, so now between 2 over 8 and 3 over 8, we were not able to think, okay, 2 and 3, is there any number in between? But see, in 20 over 80 and in this 30 over 80, can there be more numbers? Do you think 21 over 80 also comes in between? Did you think about this? Okay, what if 22 over 80? Okay, before this, let us take 29 over 80, 28 over 80. And in between, they are going to be 23, 24, 25, 26, 27, all over 80. So see, in between 2 over 8 and 3 over 8, there are so many numbers. Okay, we just multiplied it with 10 and so many numbers came up with. Do you think you can represent them on the number line? And where are these numbers? Okay, for that, let us take this one thing. Let us take this one thing that there was 2 over 8 and 3 over 8, right? How we represent is 0 over here, 1 over here, 2 over here, 3 over here, 4 over here. Let us take only a few numbers for representation. How do we do this, right? And only these many. Okay, now above these, below these numbers is 2 over 8 and 3 over 8. So we just put over 8, over 8, over 8, over 8, and same goes here. So this is how we can represent the rational numbers. And 0 over 8, what do you think it is? Yes, it's 0. So 0 as it is. So see, this is how we can represent the rational numbers on the number line. And now we know how to represent rational numbers on the number line. But what about these numbers? So what are these numbers lying between? 20 over 80, 30 over 80, in between all of these numbers. How are they going to be in between? So see, these numbers 2 over 8 and 3 over 8, they are fractions, right? They are lesser than 1. So they were lying on the number line. They were lying on the number line in between somewhere in the integers number line, right? Because these 4 is obviously bigger than these numbers, or we can say 2 is bigger than 2 over 8. 2 pizzas are always bigger than 2 over 8 pizzas, right? And 3 pizzas are always bigger than 3 over 8 pizzas. That means the integers are always greater than rational numbers. Rational numbers that we just found out here. Okay, so now we know in between there are many numbers that are existing. And you know, if the number is like 5 over 10, we can write it as 0.5, right? So these numbers are called as what? When we are represented like this, these are called as decimal numbers. Decimal numbers. Okay, so now we know about decimal numbers as well. Those ones which are represented with a decimal in between are called as decimal numbers, right? Okay, so now we know about all of these numbers. But what if there are numbers which are 0.5? This is 0.625. Okay, here is also a decimal. And I write a number 0.3148, 7214, 3218, and so on it is going. There are many numbers after this. Can you find out what is the difference between the numbers which are here, here, and here? So the difference, yes, you have found it right, that there is no so on, there is no so on, but there is so on. So there are numbers which are such that they keep on going and they are not ending. So the numbers which are ending and the numbers which are not ending, there are two types, right? The ending ones are called as terminating in maths. Terminating numbers. The not ending ones are called as non-terminating. Non-terminating. Okay. So now we got a gist of this, what are terminating and non-terminating. Now I show you one number. Do you think you have seen this somewhere? Let us take root 2. Do you think you have seen this? The answer of this is 1.414, and there are many numbers after this. You must have heard about pi, 3.14. There are many numbers going on and on after this. There is root 3, 1.732, and there are so many numbers after this. So what are these numbers? Yes, you're correct. These are non-terminating numbers. So, these numbers, do you think these are integers, whole numbers, natural numbers, or are these rationals? So, when we saw this, that these type of numbers cannot be put anywhere in any category, we called that as irrational numbers. Irrational numbers. So, what do you think? Now, what is the representation of this? I told you na, I is going to come somewhere. So, this is where it was coming. Represented by letter I, or like this. Irrational numbers. So, now we have discussed so many types of numbers. Do you think there can be any more numbers other than this? I show you a little glimpse. Now, look here. What are these? Can you guess what type of numbers are these? And do you know how to find 5 rational numbers between 3/5 and 4/5? Well, think of a way, because this is what we are going to discuss in the next session. Just make sure you're finding out the numbers and then match it with me, that if you are correct or not. Alright? So, thank you so much for coming here and joining and watching our session. Take care. Bye.